Okay, so here we're talking introduction to, oh my god, 100%. Okay, introduction to something called numeric computation using Numpy. So Numpy is a module like the other modules we have seen before. So it's one of those modules. It's a third-party module, meaning that it does not come with Python on its own. Okay. So this Numpy module, as we're going to see, allows us to do calculations very, very fast, and also in a more simplified way, as we are going to see. The reason why this is a case is because on its own, as much as Python is easy to learn, as we are finding out, it is not very good on its own with doing calculations. However, there are other languages, computer languages, which are very good at this. For example, there's a language called C, and also there's a language called Fortran. As much as these languages are very good at computation, when it comes to ease of learning, they can't match Python. So the ease of learning and use does not match Python. So that's what Numpy basically tries to bring to the table. It tries to bring to the table the power which you have with these other languages, C and Fortran, and so that you can do calculations. Okay, the person who developed Numpy is this guy, Travis Oliphant, some PhD student somewhere. I think these days he's a doctor. And the first version of Numpy was created in 2006. So it's now we are in 2021. So 2006 is like 14 years ago. Okay. There were other arrays, other modules which are there, which tried to do this computational stuff, numeric computation. But what they actually did, what this guy did was he combined two different modules. There was something called numeric and some other one called Numpy Arrays. So these two different modules, he combined them, then came up with Numpy. So as we're going to see, yeah, it brings a lot of stuff to the table. And let us see what we have. So the first question is, why would you want to use Numpy? That's the first question you want to answer. Why would you want to use Numpy? There are a couple of reasons why you'd want to do that. The first one is something called, Numpy gives you access to something called an n-dimensional array. So an n-dimensional array is basically something which looks like a matrix. In mathematics, the n-dimensional array, the equivalent of an n-dimensional array is something called a matrix. So it gives you access to something called an n-dimensional array, which allows you to do calculations with matrices and also calculations with vectors. The other thing is you have access to mathematical functions like sine, cosine, tangent, logarithm, all those kind of mathematical functions. You have access to those mathematical functions and they make life quite easy. So out of the box, you get all these access. Then of course there is the other thing about performance. Numpy is very, very fast. And the reason why it's very fast is because it is the code which Numpy runs on is based on another language called C. Other codes are also based on another language called Fortran, and these codes have been there for a very, very long time, and yeah, people know how to use them. They have made them much faster, and yeah. So there's that. It's based on some proven stuff. Then apart from the performance, there's also the ease of use. The syntax for Numpy, how you use Numpy, is the same as how you have been doing with Python so far. And the other thing is you don't really have to buy Numpy. Okay, so it's kind of free. So these are some of the reasons why. So it gives you access to arrays, Then it gives you access to mathematical functions like trigonometric functions, logarithms, random number generators, also something called Fourier transforms, and also algebra routines, like when you want to find the determinant of a matrix, or you want to find the inverse if you've got a very large matrix. If you try to do that by hand, it's going to be very, very difficult. But when it comes to Numpy, all these things are already there for you to use. Okay, and there's the performance. The performance is very good because it's based on very fast code C, and of course the ease to use. If you have, like, you have been learning Python right now, things should be very easy for you to understand and actually try to use Numpy. So the first thing we're going to do is we want to import Numpy. So the way we import, like we have been doing before, is we use the keyword import, this import. So we start with import, then the name of the module you want to import, which is Numpy, but we want to use an alias. And usually Numpy, the alias we use for Numpy is something called NP, which is short for numeric Python. The N is for numeric, then the P is for Python. So that's how, in short, we refer to Numpy. Then, if you want to see what does Numpy bring to the table, you print out, you can list, you say dir, then the module, what you want to see, then when you do a print, this is what you get. So you get a lot of things. For example, there's something called a range here. There is a minimum, a max, a minimum. There is something called arccosh, the arccosine, this arcsine. Then something called arctangent here. So there's a lot of stuff which comes with Numpy. What other things? As you can see, there's a lot. There's this one here, cell. There's a lot of things, really. If you look at all these things, this is basically a bunch of functions which you will have access to. So out of the box, you have access to all these functions and you can use them. You don't have to build anything new. Are we clear? So the only thing you need to do is you need to learn how to use these functions. And that's what we are going to do. How do we use and how do we make use of these functions? Okay. Are we clear? With the import, have we understood how to import, why we did it like that? Hello, Brian? Is it clear with what we have done? Hello? Just a minute. Okay, so you get access to all these things. So here we do an import of Numpy. Then we look at the functions which are available for you when you use Numpy. So a lot of things which are there. Now, we are not interested in everything which is here. We are interested in a few things. And basically, we are particularly interested on how we use Numpy. Now, one of the things we want to do for us to actually realize the the benefit of using NumPy is we need to create what are called NumPy arrays. Okay, especially one-dimensional NumPy arrays. So that's what we want to do. Now there are a number of ways of doing this. How to create NumPy arrays. There are a number of ways of doing this, and we are going to look at least 3 or 4 ways of doing that. Of creating these NumPy arrays. Now, the first method which we're going to look at is we're going to create an array using a NumPy function called array. Now, this array function, if I check under here, I look for something called array, arrange across around. It's this one here. This is what you're interested in. So this array function there, highlighted here, allows you to create an array from a list. Are we clear? So array function, array, not a method, but array function, array function or array method allows you to create array function allows you to create a NumPy array from a list or from a tuple, and that's what you're going to see how it does. So let's get some help on how to use it. So you start with np. That's how you access anything. Now once you have imported NumPy, since you have imported NumPy as np, so we're going to access everything with np. Then you put a dot, then array. So this should be able to get you some help on what this thing does. So what does it do? So basically here it says creates an array. So that's what it does. NumPy, this array function creates an array. Are we clear?
Yes.
Yeah, it creates an array. Now this array which it creates, you can create this array from a list, or you can create this array from a tuple. And for it to work, it needs this. So you need to give it an object. And this particular object which you need to give it can be in the form of what? Yeah, it can be a list or it can be a tuple. And there must be some examples down here on how that can be done. For example, here you say np.array, then you give it a list. This is a Python list because it starts with a square brackets, so you would 1, 2, 3 like that. Or you can use a tuple. It depends on what you want. So in our case, what we're going to do is we'll try to create an array from this list. A list of 1, 2, 3, 4. That. So this list of 1, 2, 3, 4, we are going to give it as input to the array function. So the resulting thing, array which is going to be stored, we're going to store it in A. Okay, so we start with np.array. So array needs an object. In this case, the object it needs is a list. So we're trying to create an array with items 1, 2, 3, 4. Then you store it in A. Now the reason why you need an array, why you create arrays, is because you can't do mathematics with lists. You also can't do mathematics with tuples. Are we clear? Are we clear?
Yes, it is.
Yes, we cannot do mathematics with lists. We cannot do mathematics with tuple. But sometimes maybe you've got a list of numbers or a list of lists, which is a matrix. Then you want to do calculations with these things. So if you want to do calculations, what you need to do is you get this list, then you convert it into an array. So when you do that, when you create your array, if you display your array now, this is what it looks like. So it starts with array, then inside you've got that, this. If you print your array, this is what it looks like. It looks like a list. but it's not a list because a list has got these commas separating each values. These commas, that's what a list has. But when you print your array, this is how it comes out, like this. Are we clear? Yes. So we have just created a Numpy array. We can even check the data type of what is it we think you've created here. Then you can say check the data type of whatever it is we think we have created. And how do you check the data type? By using the function type. So you say type, then a, you give a there. When you do that, then it tells you this is what you've done. You've created a numpy dot nd array. Are we clear?
Yes. Yes.
So with this method, you have succeeded in creating something called an nd array. Nd arrays are just what you call arrays. N is for n dimensional. Okay, so in this case, what you have created is a one-dimensional array. Okay. You can also create an array from we have just created an array from a list, but you can also create an array from a tuple. So if you've got a tuple and you're happy with this tuple, then you want to convert this tuple into an array, you can do that. So here we're saying creating an array from a tuple. That can be done also. So we're going to, but again, what we are using here is the array function. So the array function accepts lists. The array function also accepts tuples. So here we've got a tuple with items 2, 3, 4, 5. So we say np.array, then inside here the tuple itself 2, 3, 4, 5, like that. Then the resulting array which is going to be created, we want to store it in B, like that. Then you do a display of B, then you print B. That's what you get. If you check the data type of B, so here if you check the data type of what you have created, check the data type of B. So type B, this is what you have. You have got numpy.nd array. So also, as you can see, using the same np.array function, you can create an array using a Python list or using a Python tuple. Are we clear? Are we clear?
Kindly repeat what you are saying. The network was breaking.
Or I was saying that using the same array function, this, you can create an array using a list or using a tuple. That's what you have seen here. We have used a list as input to the array function. We created an array. We have used the tuple. We have also created an array like this. Is that clear?
Yes. Yes.
Okay. Now, there is also another way of creating an array. If you want to create an array, but you want, basically what you want is a bunch of numbers which are sequential. For example, 0, 1, 2, 3, all the way up to a certain value. So you can create an array using numpy, using what is called the arrange function. Arrange function. This arrange using numpy arrange function. So you can do that. Using something called the arrange function. This arrange is not something which is without. It comes with NumPy. So where is A? And then range. So A range, AR. Here it is. There it is, the A range. So you can use that function to actually create an array, A range function. And how do we do that? Now this A range function is basically a copy of the range function which comes with Python. Remember what range does? Range creates a list of numbers in steps of 1 if you don't specify anything, but there is a version of that range function in NumPy that is what is called the A range. Okay, and this. So get help on A range function, NumPy A range function, NumPy A range function. So we say np, since it's there in NumPy, np.arange. When you say np.arange, what you get? So here says A range. So for A range to work, you need to have a start. This is an option. You need to have a start. You need to have a stop. A start is option, but you definitely need to have a stop. Then also you've got the option of having a step size. Then you can also the data type. So basically here, return evenly spaced values within a given interval. So this one is going to give you evenly spaced values within a given interval. So it's going to give you an array which has got evenly spaced values. Okay. So in our case, we do the following. Say np.arange, then we give it 11. So when you do this, what this is going to do is going to create an array of numbers starting from 0 up to 10. Okay, then that list array is going to be stored in C, and if you display C, this is what you get. So you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you do a print of C, this is what you get. If you check the data type, of C, type C, again you see that what you end up with, what you have created with C is actually another array. So this is the other way of creating arrays, by using a range function. This A range is similar to the one you have in Python. You can specify the start point, you can specify the end point, you can also specify the step size. Are we clear?
Yes.
Yeah, so all those things can be specified. You have seen, I think we saw how we're using the range function with in Python, that side. Okay. So the other thing you can do if you want to create an array is to use something called a function called linear space. So you can use a function called linear space, Linspace.
So arange is simply the short form of saying array range, right?
Yes.
Okay.
Yeah. But it works like the range function. You remember the range function?
Yes, I do.
Yes. So it's that is a NumPy version of that function. So A range is short for saying array range. Yes. Correct. So there's another one called Linspace. This Linspace function does something similar to A range, but it does it differently. So with Linspace, what it does is you give it the start point, you give it the end point, then you tell it how many numbers you want in between. Okay? So A range just gives it a start. For A range, you give it a start, then you give it a stop. Then it generates evenly spaced numbers. If you don't say any step size, it will try to do in steps of 1, like in this case, the way it did here. Are we clear?
Yes.
Yeah. But you could have also, in the case of arrange, like for example, you could have also said, oh, you want to start from somewhere, you want to start from 2, so you put a start point of 2, then you want your stuff in steps of 2 or 3, you include the step size. So that wouldn't be a problem. Okay, so like in this case here, where what these examples here, so here it for 3, it just generates numbers from 0, 1 to up to 2. Then the same thing happens here. But if you give arrange 2 numbers, it starts from 3, then it goes up to 6. So you end up with 3, 4, 5, 6, like that. If you do this 3 up to 7 in steps of 2, so this becomes a step size. So in our case here, we could say, for example, np dot arrange. We could say, okay, we're going to start from 3, we're going to 11, like that. If we do that, this is what we get. We're starting from 3, we're going up to 11. So we get 3, 4, 5, 6, 7, 8, 9, 10. So this is your start point, that's your end point. But you can also say you want this same thing, but in steps. Let's say you want it in steps of 2. So you start from 3, you go to 11, but in steps of 2. If you do that, this is what you end up with. So it's very, very similar to that range function which we are familiar with in Python. Are we clear?
So for this function, when you include another number,
if you include 2 numbers like this,
then just start and stop.
yeah, start and stop. But the stop is not included. As you can see, the 11 is not being included in this thing.
Yes.
Then if you have 3 numbers, this is going to be the start, this is going to be the stop, then this is going to be the step size. So you're given those numbers in steps of 2. So you start from 3, then the next number, instead of giving, is going to be after 2, is going to be 5, then 7, then 9, like that.
Okay, so if we had in the brackets, let's say 3, and then stop 21.
Stop 21. Oh, okay. Let me do this. So if you had 3, then 21,
and then 3.
then 3. So this is what you get. You get 3, 6, 9, 12, 15, 18.
Okay.
Yeah. Are we clear?
Yes, it is clear.
Yeah. So this is another way of creating an array using the arrange function. So you have an option whether if you just give it one argument, it will generate a bunch of numbers. If you give it 2 numbers, one number will be used as the first number will be used as a start, the second one as a stop. If you give it 3 numbers, the first number will be used as a start, stop, then the third one is going to be used as a step. Okay. Now, Linspace has got something similar. Okay. Linspace has got something similar to that, to this. So in this case, when we did the help, what was it? So what are the things? Start, stop, step. So in this case, what we did here, so this is going to be our stop. So our stop is 11. What? No? Oh, okay. No, this is good. Okay, that's our stop is 11. Then here, this is our start. Then this is our stop. Start, stop. Then that's our step size. Okay. Now Linspace tries to do something similar, but it does it in a different way. Now, here it says you have a start. You need to have a start. Then you have a stop. Then of course by default you've got 15 numbers. If the number of between start and stop, you want to generate 50 evenly spaced values. So here it says returns num evenly spaced samples calculated over an interval start and stop. So this works a bit different. So in this case, what we have here is you have, so we have a start point, which is this. That's your start. Then the next one is, this is your stop, or I can just say start. Then that's your stop. So you start from 0, you're stopping at, this is 2 pi, then you want 50 values. Between 0 and 2 pi, you want to have 50 values. When you do that, when you run it, then you print display t, so this is what you get. These values are 50. Okay, if you do it.
So,
yes.
So, in short, if we were to use, initially what we are using the numbers like 1, 2, those are bigger values. That's why the numbers between them were easy to obtain. But for these ones, the demarcations are very small, or the steps are very small.
Yeah.
Okay.
Because of for example, we can start from what's this, 0, right? Let's go up to 100. Okay, so let's go up to 100 if we did something like this. Okay, but the problem is because we want to use this thing for something else. But anyway, let's see, 2 pi. We can create another example, 2 pi times np dot pi. We can create another example which we can use. So let's print this. First we see, let's create another example where we say np dot linspace. So the start, let's say, is 0, then 1 to the stop is 100. Then how many values do we want? 50 values, right? Between 0 and 100, you want 50 values. So if we do that, this is what we end up with. So we are starting from 0, then we're ending at 100, but between these, we want 50 evenly spaced values.
Okay, so for the Linspace, the number that follows after the stop value is the number of demarcations that you want.
Yes.
Okay.
Actually, it's a number of values you want between 0 and 100.
Okay, and then the previous one, those were the spaces that we're supposed to take.
Yes. That was the space you're supposed to take. Yeah, so that's the difference here. So if you, again, with T, if you check for the step size, the type, not the step size, the data type of T, which you've created, type T, there. So it's an array. So basically, these are the 4 basic ways of creating arrays. Are we clear?
Yes.
Of course, if you want, we have seen how to find the type. What is it you have created by using the type function. For A, you say just A, type A, then you get something. So use the type function. So type A tells you, okay, this is a Numpy array. Same for B, it's a Numpy array. Same for C, it's a Numpy array. Same for T, it's a Numpy array. So we have created these arrays, 4 different arrays using basically 3 different types, or 4 different types, whichever way. Because the first 2, A and B, we created using the array function. Then the third one, C, we created using A range. Then the other one, T, we have created using Linspace. Are we clear?
Yes.
Okay. Now, Sometimes you're interested in finding out what type of information is contained in an array. Usually arrays contain numbers, but those numbers could be either integers or they could be floats. So if you want to find out what type of information is contained in an array, in the numeric type of array elements, then you use an attribute called dtype. So you start with the name of the array, then you put a dot, then you type this dtype. This dtype is short for data type. So you want to find out what kind of information is in array A. If you want to see if you want to print A, you can print it. You have to use a print function. But if you want to find out what type of information is in array A, you say a.dtype. When you do that, you see that it actually contains an integer, an int 64. Are we clear?
Yes.
So this is how you get the data type which is contained in an array. If you do the same thing, b.dtype, for the one we created using the tuple, you also get an integer. So the data type is an int 64. There's this other one we created using arange, c.dtype, that is also an integer. But there's the other one, the t. Now if you look at the t, what we have with t is these numbers. These are numbers with decimal points. So how does that come out? If you say t.dtype, t.dtype you get is a float 64. There. So that's how you get what kind of information is contained in an array. Are we clear?
Yes.
Yeah, this is how you get the information which is contained, what kind of information is contained in an array. The other thing you might be interested in is, okay, so these arrays have got information. How much memory, okay, is each element or item in the array, how much memory is it consuming? Okay, so for you to do that, you use an attribute called item size. So you want to find out what is the size of each item in this array. So how do you do that? You start with a.item size. So this item size gives you 8. Now this 8 is in bytes. So 8 bytes. So integers each integer occupies 8 bytes of memory. Then you move on to b.item size. That's another 8 bytes. Then for c.item size, that's 8 bytes. Then the float, you also get an 8 bytes. So all these numbers, each item is occupying, it's using up memory size of 8 bytes. Is that clear?
Yes.
Yeah. So you don't have to 8 bytes. If you've got a hard drive which is maybe 1 terabyte, you never have to worry about how much space your numbers are going to occupy. Okay. Then these arrays have an attribute remember they are n-dimensional arrays. So these arrays have an attribute called shape. So this shape attribute is what you use to see what kind of array you have. What is a shape? How many rows and how many columns does it have? Are we clear? Your array can be made up of a certain number of rows. It can also be made up of a certain number of columns. So how many rows and columns do you have? So in this case, you use the shape attribute, say a.shape. So a.shape. So we get this. Now when you look at what you're being given, what is this you're being given here? What kind of Python thing is this? You're given as an answer.
It's a list.
Is that a list? Are you sure? No, that's not the list. That's not a list. It looks like a list, but it's not a list. What is it?
It will be a dictionary.
No, it's not a dictionary. That is a tuple. Are we clear?
Yes.
Yeah. But basically, that also shows me that studying is not happening properly. This is a tuple. This is a tuple with one value. Now, the value in this tuple, this value 4, this, when you've got a tuple like this is a tuple with one value. So when you've got a tuple like this 4 is telling you the number of columns. Okay? So this is an array with 1 row and 4 columns. If you look at A has got 4 values in it, 4 items in it. If you go back to A. So that's what the 4 is for. If you go back to A, where is A? A, here. You see? 1, 2, 3, 4. So this bit, this side, like in this way, that is one row. Then you count the number of columns, like that. Is that clear?
Yes.
So what you have there is a tuple. Okay, so when you look for the shape, what you're given is a tuple. Okay, and that tuple, if in our case like this, the arrays you have created are just a single row with a bunch of columns. So you're just given the value 4, like that. So that gives you the shape of the array. There. Then if you move on to B,
Okay.
yes, B.shape, with B.shape again, this is what you get.
4 columns.
Yeah, so 1 row and 4 columns. Now for C, you're going to get something different. For C, this is what we get. We have this. So this is 1 row and 11 columns. So there are 11 values there. Then for T.shape, this is what you get. You get 1 row and 50. This 50 is the number of elements we want, the number of items we wanted between the 0 and the 2 pi. Are we clear?
Yes.
So yes.
For the row, how do you get its value?
No, right now when you're given like this, okay, when it comes out like this, it means that the row is 1.
What about if it was, let's say, maybe 50 comma something? It would mean that there are 2.
Yes, so if it was 50 comma something, it would mean that you have got 50 rows and 2 columns. 50 rows and 2 columns. Yeah, if it was 50 comma 2, so that 50, that would be for the number of rows, then the 2 will be for the number of columns. Yeah. Now you can also achieve the same results of getting the shape. We have used the shape attribute, but there is a Numpy Shape function. You can use a Numpy Shape function. So you can say np.shape, then inside that shape you give the name of the array. So you can say np.shape, then inside here you give the name of the array, whose shape you want to find, then you get the same result. So you get this np.shape, then B here, you put in B, then you get your 4, np.shape, then C, get your 11, np.shape T. The result is identical. So you can use the shape attribute. When you're using the attribute, you start with the name of the array, let's say a.shape or t.shape. But when you're using the shape function, you start with np.shape, then you give this function the name of the array. like this. Are we clear?
Yes.
Okay. Then of course, sometimes you're also interested in finding out what is the size, how many bytes, because remember we have got how many items, item size, how many items each item is actually having, but you also want to find out how many items are in this array. Are we clear? So if you're interested in finding out how many items are in an array, then you use an attribute called size, but there's also a function called size. So you use an attribute called size and a function called size. So how do you use attributes? Attributes similar to shape. So you start with the name of the array, a.size. So how many elements do you have? You've got 4 elements in A. B.size. How many items do you have in B? You've got 4. C.size. How many items do you have in C? 11. T.size. How many things do you have in size? You've got 15. Is that clear? How these things work?
Yes. So now, if you're looking at size, is it going to give the actual bytes of each byte?
No. How many items? It counts how many things are in how many items.
Okay.
Yes. If you want the bytes, it's item size.
Okay.
Yes. So item size times the size should give you how many bytes.
Okay.
Yes. But there's also another way of getting that, which we're going to see. What are the number of bytes the whole array is using up? But you can also use a function called size. In this case, size return the number of elements along a given axis. And in this case, so you say np.size, then you give it the array, so it gives you 4. np.size, then you give it the array b, you give it to 4. np.array c, like that. Then np.array t, it gives you 15, like that. So you have a choice. Either you use the attribute size or you use the function size. It's up to you. Are we clear?
Yes, it is.
Okay, so we are the reason why I am moving so deliberately and so slow is because literally our course depends on this. If you already knew Python, I would only have to teach you this stuff. Then you could start. Are we clear? So I want you to understand how things are happening so that there is no confusion about this. Then of course, then comes the number of bytes, the question you're asking. If you want to check out how many bytes an array or the items in an array are using, then how would you do that? So there's an attribute you can use for that. That is called n bytes. N for number of bytes. So you start with the name of the array, A, then n, the number of bytes, n bytes. So in this case, remember we have 4 items in this array. Then each item is 8 bytes. So 4 times 8, that should give us 32 bytes. So we get 32. That's the number of bytes. So the number of bytes you've used, an array is going to use, is equal to the number of items multiplied by the space or the memory used by one item. So in this case, each item is using 8 bytes of memory. Is that clear?
Yes.
That's how you end up with 32 bytes. Then b.n bytes. Again, b has got 4. Then 4 times 8, that gives you 32 bytes. Then C has got 11 items. Then that 11 times 8, so that should give us 88 bytes. There. Then here we have T has got 50 items. 50 items times 8 bytes. 50 times 8, that should be 8 times what? That should be what? 40? 400, yes. That should be 400, young guy. And that's what you get. So you get 400 here. So that's how you work out the number of bytes. There's an attribute you can use for that. Okay. Then we have seen how to get the shape. The shape gives you the number of rows and the number of columns. But then there's also something called the number of dimensions. Is it a 2-dimensional array? Is it a 1-dimensional array? Stuff like that. How do you get the number of dimensions? And if what you have is a 1-dimensional array, then that 1-dimensional array basically can be used to represent something called a vector, a column vector or a row vector. But when it comes to matrices, matrices are basically 2-dimensional arrays. Okay, so in this case, if we want to find the number of dimensions, n-dim, which is number of dimensions, use the attribute n-dim. So you start with a dot n-dim. So this is going to give you the number of dimensions. So this is 1. So a 1-dimensional array is basically a vector. So what we have been creating here, these are 1-dimensional arrays, vectors. B dot n-dim, this is going to give you 1. C dot n-dim, this is going to give you 1. T dot n-dim, this is going to give you 1. So what we have created basically, these are 1-dimensional arrays. Are we clear? Yes. Okay. Now let us see if we can actually do the promised mathematics. How does it come out? So basic mathematical operations with Numpy arrays. So the first thing we can do is actually, with arrays, you can do addition. You can do addition. So here we have A, we print out array A, then we print out array B. Now this array A and B, they have got the same number of items, 4. So if you do A plus B, what you get is actually another array, 3, 5, 7, 6. So how does it work? The 1 is added with a 2. So 1 plus 2 gives you 3. The second element, 2 plus 3 here, gives you the 5 you have here. Then 3 plus 4 gives you this 7. Then 4 plus 5, this is what gives you this 9 here. Are we clear?
Kindly repeat.
The items, when you have, I've printed out A here, array A, I've printed out array B. So the items are added according to their positions. So the first items are added, the second items are added together, third items are added together, fourth items are added together like that. So in this case, A plus B is giving us this array. And how did we get here? It's by doing 1 plus 2. These are the first items in each array. So the first items are added.
Okay. What about if one of the two, maybe A had more numbers?
You would not be able to do that. So they have to have the same number of items.
All right.
Yes. That's the other requirement. That's what makes arrays fast, because they're always adding things with the same number of items. Okay? Okay. So in this case, you have 1 plus 2. This gives you 3. You've got your 2 plus 3. That gives you 5. You've got your 3 plus 4. That gives you this 7. You've got your 4 plus 5. That gives you plus 5 here. This what gives you this 9. You do a print of this. This is what you have. There's another way you can do this. So this is the thing of doing. But you can also use a function called add. Numpy add function. So with an add function, you just say you help with add like that. What do you get? So this is what's so yeah, there's a bit of some stuff, but let me just show how it works. Okay. So here, np.add, then you put the arrays you want to add. So the requirement really is that these two arrays should have the same number of items. So when you do an add, this is what you get, which is similar to what you have here. 3, 5, 7, 9. This and this. So if you don't want to add using the plus, you can add using the add function. Are we clear?
Yes.
Yeah, if you don't want to add using that, you can use the add function. So that's how you carry out addition. You can add as many arrays as you want. In this case, we just created 2 for demonstration purposes. You can also carry out subtraction. Now subtraction is done using a minus sign. Again, there's a small requirement that the number of elements should be the same. So a minus b. So a minus b, if you do that, this is what you get. Like that. So each element, if you print a, where is that? Print array a. So I print a. So I print a. Print a. So that's my a. If I say print b. Print b. Print b. That's b. So now you're doing a minus b. So that's 1 minus 2. That gives you minus 1 here. Then 2 minus 3. That gives you the minus 1 you're seeing here. Then 3 minus 4. That gives you the minus 1 you're seeing here. Then 4 minus 5. That gives you the minus 1 you're seeing there. Are we clear?
Yes.
Okay, you can also do a print of these, get that. You can also use a function called a Numpy Subtract, which comes with Numpy. So you can say np.subtract ab. If you do np.subtract ab, this is what you get. If you can also do np.subtract, now you kind of switch up things. You can say b minus a. If I say b minus a, I'll get positive numbers now. If I do that, this is what I get. So subtract, it says add, subtracts, not add. Okay, are we clear? On how would add and subtract arrays? So these are required simple mathematical things which you need to do with arrays. There's another one, it's multiplication. You can multiply things. So as usual, there's a print a. So let's copy that, bring it down. Print a. Print a. Print b. Okay, so you can multiply a and b. So in this case, you multiply, it's going to be 1 times 2. So if I do a times b, that's what I get. So how do I get this? So 1 times 2, that gives me 2. 2 times 3, that gives me this 6. 3 times 4, that gives me this 12. Then 4 times 5, that gives me this 20. So you can achieve this multiplication. You can also do the print of that like that. Or you can use a Numpy function called multiply. So you say np.multiply, then you put in the arrays you want to multiply. So in that case, this is what you're going to get, which is the same thing. Or you can reverse it. If you reverse it, you can say b multiplied by a. The result is still basically the same, since you're doing element by element multiplication. Are we clear? So we have looked at addition, subtraction, multiplication. Next is division. You can also divide elements. So in this case, we're saying a, whatever is in a. So I say print a, print b. If I do that, so you say print a as a, then print b. I take this one up a bit. So that is a and b. So if we divide 1 divided by 2, it will give us something. So here a divided by b, if you do a division by like that, this is what you get. So this one is 0.5, then that, then this, then that. So in this case, you have 1 divided by 2, that's 0.5, then you've got 2 divided by 3, then you've got 3 divided by 4, then you've got 4 divided by 5. So you get the result like that. You can do a print like that. You can also have access to a function called divide. Like that. So in this case, you end up having np.divide ab, and the result is the same. Or you can decide to say you're going to do b divided by a. If you do that, you end up with something like this. Is it clear? What's happening? Right?
Your line is breaking, kindly repeat.
Oh, this was for division. So you said we can divide using this /. So again, for division, you're going to divide 1 divided by 2, you get your 0.5. 2 divided by 3, you get your 0.6, that. Then 3 divided by 4, you get your 0.75. Then 4 divided by 5, you get your 0.8. So again, division is done. The first items are divided by each other. The second items are divided by each other. The third items like that. That's how it's done. It's called element by element division. But you can also use a function called divide, with a Numpy function called divide. So np.divide, then just put in the arrays you want to divide. Like this. Is it clear?
Yes, it is.
Okay. Then then there's another function called how to exponentiate. Exponentiation. So in this case, when you're trying to exponentiate something, this is how you do. So a, then 2 stars b. So that's how you do exponential. If you do that, this is what you get. Now, before I do that, again, there's a print of a. Print of a. Print of a. So print a. Print a. Then you print b, print B. Okay, so in this case, when you do this, A to the power B. So basically what you're saying is 1 to the power 2. 2, that's 1 to the power 2 is 1. That's why you've got a 1 here. Then here you're saying 2 to the power 3. 2 to the power 3 is 8, which is that here. Then you're saying 3 to the power 4. 3 to the power 4 is 81, which is what you have there. Then you're saying 4 to the power 5. 4 to the power 5 is this value here, 1024. That's how you would do your exponentiation, like that. You can print the result like that. But you can also use another function called, are we clear on this? How you do the exponentiation? Is it clear? Okay.
Yes.
But you also have access to a function called the power function. Numpy power function. Numpy power function works like the power function we have in Numpy in Python, but except it's the whole word power. So you say np.power, then the array at the bottom, then the array which is going to be the power, and you do that, this is what you get. So you get a result which is identical like that. Is it clear?
Yes, it is.
Yeah, so this is how, so for you to do this basic mathematics, addition, subtraction, multiplication, division, exponentiation, you need to make sure that the arrays have got the same number of items. You can't add or subtract arrays which don't have the same number of items. Are we clear?
Yes.
Okay, so that is a very, very good requirement. Okay. The next bits, how much are we left with? Universal functions, and broadcasting, indexing, yeah, slicing. I want us to stop at, anyway, let's see what you can do, but it's quite a bit. I'm afraid it might be too much. I want us to probably split this thing so that maybe we can stop at 17 hours. If we don't finish at 17, whatever is left, we can continue next week. I don't want us to do a lot of information at once, because that's going to, that might lead to confusion. Okay, so the other thing is there's something called universal functions. Most of these so-called universal functions are actually trigonometric functions, and Numpy has a lot of these, like sine, cosine, exponentials. These functions called universal functions, they are there and you can use them. For example, trigonometric functions. Numpy gives you access to trigonometric functions. And in this case, we start with P. So we print the array P. So this is our P. Then there's the sine function. Get the sign of the array T using Numpy sine function. So there's a function called sine in Numpy. So here, say np.sine then t. So this np.sine is going to work out the sine of each of these numbers. So that's what it's going to give you. So the sine of each of these numbers is this. So you get the sine of each of those numbers. If you make a print, you get something better as this. So each number, for each number, all the 50 numbers at once, it works out what is the sine of each of those numbers, which are in the array T. Then it gives you what the sine is. Are we clear?
Yes.
Yeah, so that's how you'd work out. If you have a bunch of numbers, then you want their sign, that's how you do it at once. Also, the cosine, you can do that. Get the cosine of t using Numpy function cos function. So in that case, you'd say np.cos, so that cosine function, then t. There. If you make a print of this, it will be much neater, like that. So these will be the cosines. There's you also get access to the tan function, get the tangent using numpy tan function np.tan t there. Then of course you can do a print. Then of course you can also you can add your values of sine, then you can also add your values of cosine, like in this case np.sine plus np.cosine here. You can do that, you get the result. This will be the result of the addition. Or you can use this. Now this is a bit messy. Remember the add, np.add. So if you don't want to do the addition with plus, you could use this, but I think it looks a bit more messy here. It looks a bit more messy, but the result is basically the same. Like that. Okay. Are we clear? There?
No, kind of repeat.
I think this one here, let me remove it. Let me just remain with this. This np.sine, we know what that is, right? It gives you an array of the values of sine using t.
I get it now.
Yes. Then also this one here, np.cos t. So now we are adding them. So if you need to add your sine t and cos t's, what are you going to get? So you can actually add them like that. Okay. The other thing I want to introduce is something called broadcasting. Now, broadcasting, remember that when you are adding or subtracting arrays, there is a requirement that the number of elements be the same. Are we clear?
Yes.
When you are adding, when you are subtracting, when you are dividing, whatever it is you're doing, there is a requirement that the number of elements be the same. However, sometimes you can have an array, then you want to add a constant number. Okay? So what actually happens in that case, for example here, if I print A, this is my A. Now I want to do this, A plus 5. 5 is just a number, 5 is not an array. So what's going to happen in this case? What's going to happen in this case is that, yes, this array will be created. There we have it. But this 5, okay, NumPy is going to create an array of 4 elements which contains 5s. Each element in that array is going to be a 5, so that when you carry out this calculation, what you end up with, you're going to end up with 6, 7, 8, 9. So there will be another array which is going to be created depending on this, how many items are in this array. So this other array from this 5, an array is going to be created which contains only 5s, okay, but it will need to have the same number of items as this one. After that array has been created by NumPy, then this addition is going to be created, so that you end up having 1 plus 5, that will give you 6, 2 plus 5, that will give you 7, then 3 plus 5, that will give you 8, then 4 plus 5, that will give you 9. This is what is called broadcasting, where NumPy creates another array which has got the same size as the one with which you're trying to multiply or divide or add with. Is that clear?
Yes.
Yeah. So you don't see it here, but inside, as NumPy is working to create another array which contains only 5s. each value in that array is going to be a 5, 5, 5, 5, 5. But the number of items has to be the same as this one. So that when you add a plus 5, the result is this. Okay? So that is what is called broadcasting. So you can add your arrays to a constant. You can also multiply your arrays with a constant. The idea is the same again. The same way we did the multiplication, that's the same way again you do with a constant here. So here is our array. So if you multiply by 5, so you say a times 5, so Numpy is going to create an array which contains only 5s, but it's going to have the same number of elements as the a. Then you carry out this thing. So in this case, you're going to have an array of 5s. So here you have 5, 5, 5, 5. So 5 times 1, 1 times 5, that is 5. 2 times 5, that is 10. 3 times 5, that's your 15 here. Then 4 times 5, that's your 20 here. Are we clear?
Yes.
Okay. You can also do it this way. So that's what is called broadcasting, where Numpy creates inside itself, it creates an array which is equal, which has got the same number of items as the array you're trying to multiply with. Now, the other thing I want to bring to your attention is that, you know, these Numpy arrays, remember when the first time we created it from a list, right?
Yes.
Yeah. So basically, these are special lists which can actually do mathematics. So most of the things you know about lists, they also work with arrays. Are we clear?
Yes.
Yeah. Whatever works with a list also works with an array. One of those things is called indexing, where indexing is where you're trying to obtain the position, the value of an item at a particular position. So for example, here we display the array B, then we want the first item, which is this one. So for us to get that, we start with the name of the array, then square brackets. Inside the square brackets, we put the index. When we do that, we get the 2. You see that? This is how we did it with lists. We can also do the same thing here. What we did with lists, we can do it with Numpy arrays. Is it clear?
Yes, it is.
You can also modify the value. For example, if you want to change this 2 to a 10, so you start with the name of the array, then square brackets. Inside the square brackets, the index whose value you want to modify, then the value you want to put there. This is how we did it with the list, like that. Then now you print out your B. Now you see that the first element of the array has changed to 10. Okay? Is that clear?
Yes.
Okay, so the other things you can do, something called array filling. So you, given an array, you can decide to say, okay, fine, I want to fill this array with certain values. For example, if we have array C, this is array C, 0 all the way up to 10. Now, if you want to fill up this array with only zeros, so you can use the fill function, the Numpy fill function, Numpy fill function. So you can use the fill function. So fill method. It's not a function anymore. It's a method. So you can use a method called fill. So you start with the name of the array you want to fill, then dot the function fill, then the value you want to fill it with. So now you want to fill every position here with a 0. When you do that, good. Then you display C. Now C has got zeros everywhere. So that's another thing you can do. Is that clear? Okay. Then I bring you attention to something called type cohesion. Array type cohesion. Now, if you remember our lists, do you remember that list we created called mixed stuff? Do you remember the list we created called mixed stuff, where we had some numbers, we have got the sun, then I don't know, we had some numbers, we have got some integers, we have got some strings in the same list?
Yes.
Do you remember it?
Yes.
Okay, so a list can have different types of data in it. However, for an array can only have one type of data. So if your array has got integers, it can only have integers. Are we clear? If your array has numbers of decimal points, it can only have decimal points. You can't have a mixture of integers and decimal points. This is what is called array type cohesion. Are we clear?
Yes.
Okay, now let us see something here. Let us first print array A. Let's do a print of array A. Let's do a print of array. We see what's in array A. So print array A. Print array A. So print A. So this is what we have in A. Then we look for what type of data is this. So data type. Okay, and we are told these are integers. Okay, so every element in this, every item in this array is an integer, right? If we look for the first item in this case is 1. If we change the value of 1 to a number with a decimal point, like in this case 10.6, if we do this, okay, then we look at A. Now you see that what it is just 10. The 0.6 has been chopped off. Do you see that?
Yes.
Yeah. So in this case, the reason why the 0.6 is chopped off is because the array only contains integers. So if you give something which is not an integer, like in this case a number with a decimal point, that decimal part is going to be chopped off. There. The reason is because of this. In an array, a Numpy array, you are only allowed to have one type of data. Only one type of data. Let's look at array C. This C, remember what it had? It has got zeros. This array C has got zeros without any decimal points. If we decide to fill up array C, then we find out, we do the following: data type of C, display d type of C. If we do this, array C, then we find out what's the data type of C. So C dot d type. With C dot d type, when you run this, again, these are just integers. Okay, if you decide to fill up C, which has got zeros, now you decide to fill it up with 4.75. Now 4.75 is a number with a decimal point. Since the array C only has integers, if you decide to fill it up with 4.75, what you end up with actually is just going to be an array with 4s. The 0.75 is going to be chopped off. Are we clear? So this is what we mean when we say in a Numpy array, you can only have data of one type. Okay. You can only have data of one type in a Numpy array. Are we clear?
Yes.
Okay. Next, however, there is a way of changing. Everything is not written in stone. You can change from one data type. You can decide, tell Python, say, oh, NumPy, say, okay, now I want this array to contain this type of data. So that you can do that. You can say, okay, now, instead of having integers, I want this array to be having this type of data. And you can do that using a method called asType. Using this method, asType method. So in this case, for example, if you decide the data type of C at the moment is integer, right? So if you decide, say, oh, you want to display C as a float 64. If you do that, then this is what you get. You end up having these dots there. Okay. But if you display C again, you see that C is still having integers. Okay. So if you want to make this change from an integer into a float permanent, you're saying C.asType float, then you store it back into C. When you do that, then you display C now. C now ends up having your decimal points like this. In this case now, if you want to fill up C with your 4.75, it's going to work properly. Then you display C, you end up with your 4.75s like that. If you decide to change again, C.asType to int, like that, then all the integer parts, all the decimal parts are going to be cut off. So you end up with this. Are we clear?
Yes.
Okay, I think you've covered enough for today. Yeah, I know there's still time, but I think let us stop here a bit, because your friend is not there and we don't want to go very far without your partner here. So I think today let's stop here. Next week when we come, we'll start from slicing arrays, then all the way up to the end. Then we look at two-dimensional arrays. So we go all the way up to the end next week. So it should not be too much. Yeah. So we'll start from slicing. Yeah. You have any questions about what you've done?
No question.
No questions, huh? Okay, that's good. I'm sure by the end of this month, we would have finished the Python. I don't know if you're excited about that. So by the end of this month, definitely we'll finish this Python business so that we can start the course. So I think when you come for your second residential school, it will be full out course, then labs also, because now we can start doing the labs, because now you have the Python you need. Are we clear?
Yes.
Yeah, so prepare to work hard when you come this time around.
Alright. Thank you so much, sir.
Okay, cheers. So see you next week.
Okay, bye.
Yeah, the video recording is going to be put on YouTube so that people can access it. That's fine with me. Okay.
Alright.
All right, cheers.
Thank you.
You're welcome.